Okay, so when we're factoring, remember what I said. This is just a recap of Algebra 1. I do not want you to change your factoring methods. You spent a very long time in Algebra 1 learning and practicing factoring. However you learn to factor, that's what I want you to stick with. I showed you guess and check because that's just universal. I'm going to show you factoring because a lot of teachers I'm going to show you earmuffs, I'm sorry, because a lot of teachers in Watchung Hills use it. So the way earmuffs works is you take your first and your last, including the sign, and you multiply them. So I'll write it out. So we're going to multiply first and last. Can we stop that, Chris, please? Thank you. So 3 times a positive 5 is a positive 15. Right, then what you want to do from that point is you are going to think of factors of the new product that add to the middle coefficient. So basically, I'm thinking of factors of 15 that add to a negative 8. So what are factors of positive 15 that add to a negative 8? Aditya. Negative 5 and a negative 3. Now, in earmuffs, this is the step that everybody forgets and makes everything wrong. So if you forget this step, you're pretty much done for. So the last, well, not the last step, but the next step is divide by the first number and variable. So we're going to take those factors that we just thought of, and we're going to divide by the first number and variable, not with the exponent. So we're just dividing by 3x. We're going to simplify. So divide by the first number and variable, and then we're going to simplify. Can I simplify a negative 5 and 3x? No. Can I simplify a negative 3 and a positive 3x? Yeah, I can divide top and bottom by 3, and I'll end up with a negative 1 and an x. And then your last step is make your double set of parentheses. And I'm going to write bottom to top. So we're going to make our parentheses, and then inside those parentheses, we're going to write bottom to top. So the first parenthesis is 3x minus 5. Our second parenthesis is x minus 1. And if you look above, that's the same answer we got when we did guess and check, right? Same factors. All right. Thing with earmuffs, it's foolproof. Earmuffs will always work, but the problem with earmuffs, especially in Algebra 2, is that we start dealing with bigger numbers. So like once we're dealing with this, like when you multiply it, you can end up like in the hundreds. So then there's a ton of factors. So that's the problem. That's the only problem I can think of with earmuffs, where guess and check, at least you're keeping it in like the smallest numbers possible. Do I care which method you use? No, I don't care. I know some teachers do some X method. I don't know the X method. If you learn the X method, do your X method. Whichever way you learned in Algebra 1, that's what I want you to stick with. All right, let's do our sample problem. Okay, the directions for all of these are to factor. Whenever we're factoring, the first thing we always look for is what? When we're factoring, the first thing we always look for is what? Critica. GCF, excellent. 24, 16, 30. Is there a GCF there? Yeah, what's my GCF here? Yeah, what's the GCF? Chris? A 2. Pull out your 2. When we pull out the GCF of 2, we're left with 12x squared minus 8x minus 15. Now we look inside our parentheses and we need to factor this further. This is factoring with a leading coefficient. We can do guess and check, or we can use earmuffs. I'm going to show you earmuffs. I'm going to show you earmuffs just to show you how numbers can get a little big. So with earmuffs, we're going to take our first and our last, including the sign. We're going to multiply them. 12 times a negative 15 is a negative 180. So this is what I was saying when we could get into some really big numbers when you multiply. The product can be big. So now this isn't so bad. We need to think of factors of negative 180 that add to a negative 8. Can we think of 2 numbers that multiply to a negative 180 that add to a negative 8? Vanya. Say it one more time. You got it. We got a negative 18 and a positive 10. Now, this is the step everyone forgets. After we come up with our factors, what should we do? After we come up with our factors, what should we do?
Divide by the leading coefficient and variable.
Good. Divide by the leading coefficient and variable. Do we include that GCF in there? No, we only divide by 12x. We're ignoring that GCF of 2. So we're going to go ahead. We're going to divide by 12x. And then we're going to simplify these fractions. I can simplify both of these fractions, which is totally fine. The first one, I'm dividing top and bottom by 6, and we're going to get a negative 3 over 2x. For the second one, I'm dividing top and bottom by 2, and I'm going to get a positive 5 over 6x. So now we're going to write out, here are our 2 fractions. Now we're going to write out the final factors. So our GCF of 2 stays in the front, and then bottom to top. So it's a 2x minus 3, and then a 6x plus 5. That GCF only gets written once. That GCF only gets written once. How would I check to make sure I factored correctly? Arsh?
You multiply everything else, so like you do 2x minus 3 times 6x plus 5, and then you multiply the entire thing by 2.
Exactly. Remember, when you're factoring, I'm asking you to work backwards. I've given you the product, and I'm asking you, what are the factors of this product, or what multiplies to this product? So once we've factored completely, if we multiply back, it should be the original problem. We're working backwards. Anybody want to see me check this? We're okay? All right. I'll give you one to try on your own, and then we'll step it up to Algebra 2. All right, I'll give you one to try on your own, then we'll step it up to Algebra 2. And I want you to factor. Someone tell me, what did you get when you factored this? Dylan.
5x minus 1 times x minus 7.
Excellent. Anybody want to see us do this? Anybody want to see me do it? We're good? Great. All right, let's step it up to Algebra 2. So I'm going to have 6x raised to the 2m plus 19 times x to the m plus 15. Everything in Algebra 2 is just Algebra 1 with a scary costume. That's all it is. Everything in Algebra 2 is just Algebra 1 disguised in something scarier, but it's the same concept. So again, I need us to factor. Directions for this whole lesson, factor. Now, this is factorable. What I'm looking at right now is I have the same variable. That's a must. We have the same variable. And now one of the exponents is double the other exponent. Do we see that? So one exponent is m, the other exponent is 2m. That's what you want. You want one exponent to be double the other. So in this scenario, what you can do, if the presentation of this intimidates you, we can change it into something that we're used to seeing. So we can use substitution, and we can say, now choose a different variable that's not there. You can't choose x, because x is already there. I can't use m, because m is already there. I'm going to use a. And I'm going to let a equal the smaller variable in exponent. So which one's smaller, x to the m or x to the 2m? Good. The smaller one is x to the m. So you're going to let the new variable equal the smaller exponent. So if a is x to the m, what do you think x to the 2m is represented by in terms of a? A squared. You got it. So what does this become? This becomes 6a squared plus 19a plus 15. Not as intimidating anymore, is it? Is there a GCF? No. All right. I'm going to just stick through earmuffs this whole lesson, but then after this lesson, I'm not going to show anything. I'm just going to go to the factored form. All right, so for this whole lesson, I'll stay consistent with earmuffs, but after this lesson, I'm not showing it anymore. I'm just going to go into the factored form. So earmuffs tells us take your first number and your last, including the sign, and multiply it. 6 times a positive 15 is a positive 90. I need factors of positive 90 that add to a positive 19. What are those factors? Sure.
Do you have to do that, like,
Substitution? No. Right, absolutely not. You do not have to use substitution. You can go straight into factoring. Yes, Claire. 10 and 9. Now we're positive 10 and a positive 9. We're going to divide by the leading coefficient and the variable. So we're going to divide by 6a. And then we simplify. The first fraction could be divided top and bottom by 2. So we end up with a positive 5 over a positive 3a. The second fraction, divide top and bottom by 3. We end up with a positive 3 over a positive 2a. Right? These are going to be our parentheses bottom to top. So it's a 3a plus 5 and a 2a plus 3. Now, here's the thing that a lot of people forget, especially when we get to the test. Everybody loves using substitution, but then what do you think happens when we come to get our answer?
You forget that you're supposed to revert it back to, like, the S.
Exactly. So substitution makes things really nice, but you can't forget to go back. You have to substitute back in for the original variables that we were in. So remember, a is equivalent to x to the m. So now we substitute back in. This is 3x to the m plus 5, and this is 2x to the m plus 3. And that is our factored form. Now, you can know very easily, so I'm just going to bring back the original 6x to the 2m plus 19x to the m plus 15. You can know right away, well, I'm working backwards. This is the product, I need the factors. I know what multiplies to x to the 2m, x to the m, and x to the m. You don't have to use substitution if you don't want. You know, in a scenario like this, do I hope eventually that you'd recognize when it's that simple? Yeah. Will all the problems be something that simple? No. Sometimes substitution will make it a lot easier because it's a more difficult base problem. All right, let's do another one. You all try this one. Again, I need you to factor, and this is going to be 8x to the 6m minus 2x to the 3m minus 21. You all do this on your own. Oh, sorry, that's an m, not an n. So 8x to the 6m minus 2x to the 3m minus 21. All right, anybody need more time? You need more time? Yeah, okay. Take your time. If you're doing earmuffs here, this is what I was saying, the number's pretty big. There's a lot of factors. The only thing I can tell you when you're using earmuffs, looking at what the sum is, for it to have to add to a -2, you know the two factors have to be really close together. So you're not going to pick like 2 and like a really high number. So it's two numbers that have to be close together because when you subtract them, they have to add to a -2. So that's a good hint for you if you're using earmuffs. All right, who has an answer for me? Simon?
4x to the 3n minus 7 minus 2x to the 3n plus 3.
This is absolutely perfect. Who needs to see me do this? Let's do it. Earmuffs or guess and check or something different? I'm sorry? You got it. Okay. So I can't, the factors for the earmuffs would have been 12 and -14. But then I'm not, because I can't like tell you how to get those. So what I can do is let me show you guess and check again, because guess and check, in my opinion, would have been a lot easier. So if we're doing guess and check, in this scenario, I would have set up my parentheses. Ryan, are you showing him or am I showing him? It's okay if you explained it to him. I'm just trying to see. Did he answer your question or do you need me to? I'm sorry? I can't hear you. He explained it? So do you need me to do this or no? It's okay? You sure? Okay. Anybody want me to do this? Yeah? Nope. Okay. Let's go then. Let's keep going. That was a little delayed.
Yeah, I was still doing it.
Okay, so we got x to the 2n plus 4 plus 7x to the n plus 2 plus 12. Don't get intimidated. Is one exponent double the other exponent? Yeah, so can we factor this? Yes. Can we use substitution? Absolutely. Do you have to use substitution? No. If we didn't want to use substitution, what would go in the beginning of each parenthesis if we didn't use substitution? If we did not use substitution, what would go in the beginning of each parenthesis? Good. X to the n plus 2. How many people are using substitution? All right, let's use substitution. So if we're using substitution, we're seeing that one exponent is double the other. So I'm going to let a equal the smaller exponent, x raised to the n plus 2. So if that's a squared would be x to the n plus 2 times another x to the n plus 2, which is x to the 2n plus 4. So now we have a squared plus 7a plus 12, and I need you to factor. Well, this is very basic factoring, right? Not intimidating at all. This becomes an a plus 3 and an a plus 4. What should we not forget to do? Plug back in. So remember, a is equivalent to x to the n plus 2. So x to the n plus 2 plus 3, x to the n plus 2 plus 4. All right, the next one. Again, do not let the look of something intimidate you. X squared plus the quantity of m plus n times x plus mn. Again, factor. For every problem, I need you to factor. Right? Is there a GCF here? No. Substitution will not help you. There is nothing to substitute here. That will not help you at all. So we are going to follow the rules of factoring. What do the rules of factoring tell us? Go to your constant or your last term. What is my last term? Mn, right? M times n. And I'm looking at the middle coefficient. What's the middle coefficient? M plus n. So I'm saying, what are factors of mn that add to m plus n? Well, the only thing that multiplies to mn is an m times n. Do I need to repeat that? The only thing that multiply to an mn is an m times an n. Well, then you check. Is m plus n? M plus n? Yes, this is easier than it looks. This is it. It's an x plus m and then an x plus n. That's all it is. Do not get intimidated by how things look. This might have been the easiest problem we did today. All right, let's keep going. Step it up a little bit more. I'm going to step it up a little bit more. What have I done? I've added another variable. But it's okay. It's okay that I've added another variable. We're going to approach this the same way. But now instead of just an x in the beginning, we're going to have an x in the beginning, and then what do we need at the end of each parenthesis? A y, because a y times a y has to multiply to the y squared. So remember, I'm giving you the product. I need to know what multiplies to that product. How many people are using earmuffs? Okay. How many people are doing guess and check? How many people are doing a method they learned in the middle school? Okay. So I will do this one with guess and check. I will do this one with guess and check, and then I'll do it again with earmuffs. So with guess and check, right, it's not so bad. We need factors that multiply to 2x squared. Well, what are the only things that multiply to 2? A 2 and a 1. So the only thing that multiplies to x squared is an x and an x. So the only way to multiply to 2x squared is a 2x and an x. Now, I need to multiply to a positive, but add to a negative. If we're multiplying to a positive and adding to a negative, both numbers have to be what? Or both factors have to be negative. They both have to be negative. Negative, negative. All right. Now, I need to multiply to a 5y squared. Do we agree the only thing that multiplies to a 5y squared is a 5y and a 1y? And we said they both have to be negative. Now, the question is with the guess and check, what goes where? Do I put the 5y with the 2x, or do I put the 5y with the x? Should I do it wrong first? Let's do it wrong first. Let's put a 5y here and a y here. We need to check the middle term. The way you check the middle term is you multiply the x by the non-x term. So 2x times a negative y is a negative 2xy. And then the x by the non-x term again. Negative 5y times x is a negative 5xy. Negative 2xy minus 5xy is a negative 7xy. Is that what we wanted? No. So what does that tell us? I need to switch the 5y and the positive y. I mean the negative y. So check again. 2x times a negative 5y is a negative 10xy. Negative y times x is a negative xy. Negative 10xy minus xy is negative 11xy. Are we good? Yes. 2x minus y times x minus 5y. So that is the guess and check. Ready for earmuffs? So for earmuffs, 2x to the squared minus 11xy plus 5y squared. 2 times a positive 5 is a positive 10. What multiplies to a positive 10 but adds to a negative 11? Negative 10 and a negative 1. Divide by a 2x. Divide by a 2x. Oh, sorry. We needed 10y squared, right? So that would have been a negative 10y and a negative 1y. So now simplify top and bottom, divide by 2. We get a negative 5y over x. Divide, oh, nope, can't divide there, so we leave that. So our parentheses, x minus 5y, 2x minus y. Same thing. All right, next one. Can we use substitution? Yeah, so I'm going to let a equal x squared. So that means a squared is x to the fourth. So now we're 2a squared minus 9a minus 5. I need you to go and factor this now. Factor 2a squared minus 9a minus 5, and then we'll touch base again. Bless you. All right, who's factored this? David?
I got x squared minus 5 and 2x squared plus
2x squared minus 5, and then what was your other one?
2x squared plus 1.
I might be wrong. Did you all get that?
Yeah.
Okay, so I might be wrong. 2x squared plus 1 right over here? Okay, I need to go a step further. Here, stop and think. Looking at this right now, something should make me hesitate. Does anybody know, even though there's nothing else we could do, but there should be some hesitation. Why? Why should there be some hesitation on your part or on my part, who's ever factoring? Somebody new, have a thought. Navia. There's an x squared. It's two terms and an x squared. When you're thinking two terms and an x squared, what kind of factoring should we be thinking? Adopt a difference of squares. So you need to check for that, because it's going to get to the point where you factor, then you have to factor again, and then you might have to factor again. You might have to keep going. So right now, x squared minus 5, is that adopts? No, because 5's not a perfect square. 2x squared plus 1, it's not, well, 2's not a perfect square, and it's not a difference. So are we done factoring here? Yeah. Do you think on the test, every problem you'll be done? No, you're going to have to keep going. Sometimes you'll have to keep going 2 or 3 times. Yes.
So can we only do dots and subtraction?
Yes.
Okay.
All right. Next one. I want you guys to try this one on your own. 4x to the fourth minus 24x squared plus 20. 4x to the fourth minus 24x squared plus 20. So you all started this. What should you have done first? I'm not looking for the answer. What should you have done first? Dylan. Good, GCF of 4. You all should have done a GCF of 4. All right, who has an answer for me completely factored? Who has an answer completely factored? Ariana. How many people got that? Yay, you all win. All right, who wants to see me do this? Don't be shy. All right, let's do this. So we have 4x to the 4th minus 24x squared plus 20. So I'm going to use substitution. I'm going to let a equal x to the 2nd, the smaller variable in exponent. So we're going to have 4a squared minus 24a plus 20. Then I'm going to pull out a GCF of 4. You pull out your GCF, we're at a squared minus 6a plus 5. No more leading coefficient, so this is just a normal factoring at this point. So we need factors of positive 5 that add to a negative 6. That's a negative 5 and a negative 1. So here we have 4, and then we have times the quantity of a minus 5 times the quantity of a minus 1. Don't forget to substitute back in. Don't leave it in terms of a. This is in terms of x. So this is 4, and then we're x to the 2nd minus 5 when you substitute back in, and then x to the 2nd minus 1. You see a variable with an exponent bigger than 1, you need to step back and hesitate. You need to double check this. So I have an x squared. X squared minus 5, is that a dots? No. X squared minus 1, is that a dots? Absolutely. You need to factor that further. So we have 4 times the quantity of x squared minus 5, and then it becomes x plus 1, x minus 1. There was a problem I wanted to do. Where is it? All right, let's step this up a bit more. Hi. You may. Can I use substitution here? We can use substitution here, but when I use substitution, can I use a? No. Can I use x? No. Can I use y? No. So I'm going to use different variables. We can use a b. We can let b equal, we'll choose the smaller x. What is the smaller x? X to the a plus 1. Now I need a different variable. What do I need a different variable for? For the y to the a. Exactly. Let's use w. I'm going to say w is going to equal y to the a. So now when we substitute in, this is going to be 2 to the b squared plus 5bw plus 3w squared. Does it make it a little bit less intimidating now? It's a little bit less intimidating. Let's factor. I'm going to use guess and check. The only way to multiply to 2b squared is a 2b and a b. And now the only factors of 3w squared are a 3w and a w. Do we agree? Now the question is, where do I put the 3w and where do I put the w? It's all positive, right? We're adding to a positive, we're multiplying to a positive, so it's plus signs in both. If I put the 3w here, 2w times 3w, isn't that a 6, or 2b times 3w, isn't that a 6bw? And then I'm going to have to add another one. Won't that bring me to 7? Right, so does it make sense to put the 3w here? No, it's going to be too big. So I'm going to put the 3w with the 2b. And then the w here. Let's check that. 2b times w is a 2bw. 3w times b is a 3bw. What's 2bw plus 3bw? 5bw. Isn't that what we wanted? So now we have our factored form. 2b plus 3w times the quantity of b plus w. Can I leave it like this? No, we need to substitute back in. So this is going to be a 2x raised to the a plus 1 plus 3ya. And then we're going to have b, what did I say b was, ya? No. X to the a plus 1 plus ya. And that's all we can do. Do we want to see this with earmuffs? Yeah? Okay, let's do it with earmuffs. So again, same substitution. So I forgot what I wrote out. What was it? 2b squared plus 5bw plus 3w squared. So we're going to multiply the 2 and the 3w squared. We're going to get 6w squared. All right, so now we're doing multiply to 6 but add to 5. So we're positive, oh, not positive 5. Multiply to 6 but add to 5, we're at a positive 3w and a positive 2w. Divide by 2b, divide by 2b. The only one we can simplify is the second one. I could cancel out those 2's. So then we're at 2b plus 3w, bottom to the top, and b plus w. Substitute back in, we're 2x to the a plus 1 plus 3y to the a, and then x to the a plus 1 plus y to the a. All right, we have 10 minutes. I have some problems for you to try on your own. Try this one on your own. Oh, sorry, wrong one. Sorry. That's why you need to do math and pencil. There we go. 6y squared plus yz minus 12z squared. All right, who has it factored? Who has it factored? Dylan.
3y minus 4z times 2y plus 3z
2y, then what'd you write?
plus 3z.
How many people got that? Good. Who needs to see me do this? We're good? All right, we're done for today.